Attached is a schematic that I used to measure the photocells, and I created one for A0 and a circuit for A1. Both of these cause the voltage to increase as an increase in light level occurs. And then I would have measured the room light and found out the A0 value, which was about 400. Did the same thing with the flashlight and found a value of 900. And then there was a center point of 650, and then I created an upper and lower threshold for the two. I have a board with two photocells, and I'm shining on the right one. And you can see the numbers on the screen are much higher for the right photocell, so I'm veering to the right. Now I'm going to shine the flashlight on the left, and the Neopixel lights corresponding to the left, and you can see the numbers are much higher for the left. And then this is shining in the center. The top green one comes on. You can see the numbers are very high for both. And then if I take the flashlight away, I'm getting very low numbers, and the middle Neopixel is turned on. Now I've taken the flashlight away and it's in the dark, and you can see both numbers are very low. Let's have a look at the program that uses the Neopixels and the photocells. First of all, we're going to download the program. So you go to File, and we'll save it first. We'll go to Tools, and in the Tools, we'll just make sure we're connected to COM7, and we're connected to an Arduino Mega 2560. All that's okay. So we go to File and Save, and then we're going to click on Verify. I'm just going to move this screen up here so you can see that there were no errors. And then I'm going to go to Upload. And now it's uploading from the computer to the Arduino board. And you can see down at the bottom there are some messages showing which state the light is in. If I can get my flashlight here, and I'll just shine on the two sensors. So this is the left-hand sensor, and it goes very high. The right-hand sensor, it's high now, and the left one is low. And all I'm looking at is the analog or the A to D converter value. Okay, and these are with both of them. Sorry, that's both in the dark. And I'm going to try to get them both in bright lights right here, and that's going forward. Okay, let's have a look at the program. So I'm going to start off with line number 1. You should always have that kind of information in your program. And I'm going to put a double line at the beginning and the end. Sorry, let's fix that up. And that's just a single line comment. But on the next two lines, line number 3 and 4, that's called a multi-line comment, and it starts off with a slash asterisk and it ends with an asterisk slash. Whenever you want to add multiple lines of comments, it's a good way to do it. And it's also a good way to comment out certain parts of your program. So on this hardware, I actually have a Neopixel. And the Neopixel, to use it, you have to include this library. And so it's called Adafruit Neopixel.h. I've included that. And on the second line, number 7, it's configuring the Neopixel operation. And the two most important pieces of information that are required are that you're indicating how many Neopixels there are on your device. I have one that has 7. And then the pin that it's attached to on the Arduino. And I've attached it to number 7. Happens to be coincidental that I used it on both. And then in line number 9 to 12, that's the setup. The two things that I must set up are the serial port and the Neopixels. So I'm just telling it I'm going to start using the Neopixels on line 11. And let's just move up a little bit here. So on line 13, we're starting the looping part of the program. On line 14, we're actually reading the left and right photocell, or left and right LDR. One's attached to A0, the other is attached to A1. And then I have 4 integer values representing the left lower threshold, left upper threshold, right lower, and right upper threshold. These are values that you will have to adjust as the sensors are exposed to different light levels. especially when you are possibly bench testing it compared to running it on the floor. And then on line number 23, I have my first if statement. And you can see those special symbols in the middle there. They're called ampersands. And they're used to AND the left and the right statement, a logical AND operation. So I'm saying if A0 integer, which is my left sensor, is greater than the left upper threshold, and my right sensor is greater than the right upper threshold, that's when I want to drive the robot forward. And then I'm doing some things with the Neopixels. First of all, clearing all of the Neopixels. That means turns them off. And then it says pixels.set pixel color. That's the color I want the Neopixel to be. And the first number that's in those brackets is the display number. Okay, there are 7 in this case. So number 2, I think, is in the top right. And I'm going to define the color and the brightness that I want to display. So there's 3 numbers there, 0, 120, and 0. They represent the intensity for R, G, and B. So if it's 0, it's turned off. If it's 120, it's about half the possible intensity. It goes from 0 to 255. So what I'm doing here is when I want to go forward, I'm going to turn, I think that's the top center pixel, I believe. And it's going to be green, and I'm going to have it a level of 120. And then pixels.show actually turns it on. Else, the other thing that's possible is if A0 integer, which is my left sensor, is greater than the left upper threshold, and my right sensor is less than the right lower threshold, then I want to veer to the left because I have bright light on the left-hand side. And then I'm going to turn on Neopixel number 1 in blue color at a brightness of 100. Then the third else if statement, or second else if statement, compares the left sensor and the right sensor to see if the right is going past the upper threshold. If it is, I want to veer to the right, and I'm going to turn on Neopixel 3, and then I'm going to make it blue in color, RGB. And then if none of those are true, that must mean I want to stop because I don't have enough light. And so what I'm going to do is print the message stop. So all of these print a message as well, veer left, veer right, stop. And in this case, I'm going to turn on the center pixel at a brightness of 100, and it's going to be in red. Okay, and once all of that's done, I'm going to, because the first column would have been the either veer left, veer right, stop, or forward. And then I'm going to use a /T. What that is a tab. So over here, it just moves it over a certain amount of even spaces. And then I'm going to print A0 integer, which is the 278 in this case. Tab it over. And then I'm going to use a print line so that after I print A1 integer, it moves to the next line. So over to the left and down one line. So it makes it convenient to see the printout in this case. I'm going to move this up a little bit so you can see those numbers. And again, I'm just going to shine the flashlight on one sensor, the left one, the right-hand sensor, and then turn it off. Okay, it takes a little bit of work to balance all of this, but you will get it. Okay, while we're here, if you want to go to set up the preferences, you go to preferences and you'll get this preference screen. If you need to make the text bigger, this is where you'll do it. If you want to, we'll go up here. And if you want to make the interface scale bigger, you'd click on this. And then when you're done, just click OK. And you can see everything is a little bit bigger. Sometimes it's easier to read that way. And this is also where you go into dark mode. So File, Preferences. And right now I'm in light, but I can go to dark, high contrast. And probably some of you will like that. I find it can be useful. It's showing you all of the different characters in different colors. For example, the text or comments are green, so this is a single line comment, multiple line comment. And if you hover over variables, you'll get information about that variable as well. Okay, it's an integer type and it's connected to A0. So very, very useful. All right, I hope this helps with the Photocell program.